We're going to look at rational exponents. We've looked at roots in the nth root of b, but another way to write an nth root would be b to the 1 over n. Or if you have something other than 1, pretty much when you're looking at a fractional exponent, the bottom of the exponent tells you the root you're taking. The numerator, the top of the exponent, tells you the power that you're raising it to. Now, whether you raise it to the power before you apply the root or raise it to the power after you do your root does not really make a difference. Remember, with a negative exponent, it really means move it to the other part of the fraction and it becomes a positive exponent. So we want to write these as a radical. Remember, the top tells you the power to raise it to, the bottom tells you the root to take. So it's really just the sixth root of an a to the first. Or here, it's just a square root of an m to the first. Here we have a root, and we want to go ahead and write it differently. So this would just be an x to the, since it's a fourth root, the bottom of the exponent has to be a 4. The exponent of 1 here goes here. Here we just have the sixth root of an a to the sixth, or a to the first. Here we'd have a y. The index here in front tells you the denominator of your exponent, which is 3. There's really a 1 here for your exponent on y. That goes here. And then we want to go ahead and work this one out also. So we want to go ahead and simplify this. It's a negative exponent, so we'll make it positive by putting it in the denominator. So it's 1 over this. So the negative exponent just moves it to the other part of the fraction. A 1/2 power, you should remember, is the same as the square root. The square root of 49 is 7, so it's just a 1 over 7. Over here, we'd have the denominator of the exponent telling you the root you're taking. The numerator of the exponent tells you the power to raise it to. Now, whether you square it before you apply the fifth root or after you do the fifth root does not make a difference. I'm going to go ahead and do it after I do the fifth root. Fifth root of 32, I know off the top of my head, is 2. And then I still got to do my squaring. And so then I end up just getting 2 squared, which is 4. So here we have a negative exponent, so I got to go 1 over this whole thing, and then the exponent becomes positive. Square root of 25, because it's a 1/2 power, square root of 25 is 5, so it's still just a 1 over 5. 16, remember, the top part of your exponent tells you the power to raise it to, the bottom part tells you the root to take. So I'm going to take the fourth root of my 16, then I got to cube that answer. Now, whether I cube it beforehand or afterwards doesn't make a difference, but I'm going to go ahead and do it afterwards because I don't know 16 cubed off the top of my head. But I do know the fourth root of 16, and that's just 2. Still have to go ahead and do my cubing, and 2 cubed is just plain old normal 8. So a lot of times if you apply the root first before you apply the power, you can do it in your head. So we have a y to the power times y to the power. You should remember y to the power times y to the power. All you have to do is just add your exponents. So you add 1/7 and 4/7, you get 5/7, which is really the seventh root of a y to the fifth power, because the bottom tells you which root to take, the top tells you the power to raise it to. Oh, negative exponent, just like what we've done before, we got to go 1 over this whole thing because it's a negative exponent. Well, that's really just a 1 over, and then it would be a cube root of an a squared. Well, remember, we don't want to leave roots in the bottom. We want to go ahead and try to get to the cube root of an a cubed because we know that that cube root undoes the cubing. So you got to think, okay, I'm going to have a cube root top and bottom, but an a squared times what gives me an a cubed? Well, that's just an a to the first. And so if I multiply the bottom by that, I got to multiply the top by that. Well, multiplying the top doesn't change it because it's just 1 times that. The bottom then just simplifies down to an a because your cube root undoes your cubing. So you'd have the cube root of a over a, which if you wanted, you could write as an a to the 1/3 over a. Wouldn't make a difference. So here, x to the power times x to the power, you add your exponents. You get x to the 3/5, which is then the fifth root of an x cubed, because remember the bottom tells you the root to take, the top tells you the power to raise it to. A negative exponent, so you got to go 1 over this whole thing, which is really then a fourth root of a 3 or a cubed. Well, we don't want to leave this root in the bottom. We want to try to get just a normal a, but to get that, we know we have to have a fourth root of an a to the fourth power, because you know your fourth root undoes your fourth power. So you got to think, okay, I'm going to have a fourth root top and bottom, an a cubed times what gives me an a squared, which is just an a to the first. So I have the fourth root of a to the first in the top and the bottom. So you multiply the top. The bottom simplifies to that. The top doesn't do anything. If you wanted, you could write that as an a to the 1/4 on the top over your a to the first on the bottom. Sixth root of 16, which is really just the sixth root of 16, or 1/6 power. And then we have a 1/3 power on the bottom because of cube root. 16, you know, is 2 to the fourth. So now you have an exponent raised to an exponent on the top, so you multiply them together, you get 2/3, because you get 4/6, which reduces down to 2/3 for your exponent. 2 to the power divided by 2 to the power, so all you have to do is subtract your exponents. And so then you end up with just the cube root of 2. Now, typically, if you start out with a root, you want to leave your final answer in the root, but you can use fractional exponents in the process of getting to that. Over here on the right, we have a sixth root, so that's a 1/6 power. And you'll notice I changed my 4 into a 2 squared, because whenever possible, you want to look at things in the smallest base possible. So now you can take your 1/6 power and apply it to each one of these on the inside, since it's all multiplication and division. An exponent raised to an exponent, so 2 times 1/6 is 1/3. 4 times 1/6 is 1/3. You'll notice that both the denominators here are 3, so we know we're going to have a cube root. Then it's going to be a 2, and remember the numerators tell you the power you're raising it to, so it'd be a 2 to the first and a 2 squared. And take a look at this one here. This would be a 2 squared on top, because that's what 4 is. 1/4 power, because you're dealing with the fourth root, and 2 to the 1/2 here. Multiply your exponents, you get 2 times 1/4, which is 1/2. 2 to the 1/2 over 2 to the 1/2, which top and bottom are the same, so it's just 1. 16, you know, is a 2 to the fourth, x squared, and it's all raised to the 1/3 because you're dealing with a cube root. Apply your exponent to each one, since it's all multiplication and division. So now you'll notice your exponent here is more than 1. It's really 1 plus a third. So it's really a 2 times a 2 to the third, because remember, in multiplying your bases, you add your exponents. So you're going to have your 2 in front. These both have denominators of 3, so you know it's a cube root. Be cube root of your 2 to the first power, because remember the numerator tells you the exponent to raise it to, and your x squared. Or if you wanted, you could work it out slightly differently, just like we were doing in previous sections. Wouldn't make a difference.